violet frequency is high and wavelength is low. And red color frequency is low and wavelength is high. Okay, so here, when see, that is why red color light is used in, in the street light, in the danger signals, or in the traffic signals they use for stop. Why? Because wavelength is large. This can be seen from a long distance. There was an incident which happened in America. A person jumped the signal, and the police caught him and they brought him in the court, and he was prosecuted. Then when the judge asked him, why did you jump the signal? Then he said, no, it was not red, it was green. It was green. Then the police argued like, no, it was red. He jumped on red. Then the judge asked him, what was the speed of your car? The speed of my car was around 60 above, he said. Then okay, no problem. We have to, because in court what happens, they have to consider both the arguments. Then they did the same experiment with 60 above speed on the signal. Actually the signal was red, but again the traffic, for the person who was investigating, he again jumped the signal. Okay, then he came back again, they told, yeah, it was green at that speed. Then, but anyways, he made a mistake. Judge wanted to, put penalty on this fellow. Then what, he raised the question, what is the speed when you approach the signal? It was only 30. Mostly everywhere it is 30 to 40, not more than that. There's a reason for that. Then they asked, it was 30. Then why do he did not put the penalty for that jumping. He put the penalty for, speeding at the road, at the junction. Understood? So that is why whenever you approach the signals, the speed will, there will be rumble strips as well as the speed will come down to 30 or 40, not more than that. Even at the roundabouts also, the speed is less. So why? Because what happens? Actually, the light is not changing. The light is not changing. What happened is, suppose this is the source, red color source, and this is the observer. Suppose there are 10 waves, like 3 waves, okay. But if the observer is coming with very high speed, what happens? These 3 waves will get very close to each other. So instead of becoming red color light, it will be seen as green for the observer. Understood? Instead of showing as a red color for the observer, it appears to be like a green to the observer because he crowded those waves. He crowded those waves. Understood now?
Yes, sir.
But
Yes,
in
sir.
some countries, if you go back to maybe Japan, or I don't know which country it is, they use green and one more color. What is it? Purple or white? Green, purple, or I don't know, some other color also they use. Red will be for danger, but for for green, instead of green they use some other color also. There is a reason.
Oh, sir, white. They use
No,
white.
not white. They never use white. Okay, they use some other color. Now
Sir,
we'll go
white,
back to the
right?
second part.
I saw in a movie over there.
No, I saw some video. It was, they were using blue color light in the traffic signal instead of green, because blue's wavelength is less. Okay, maybe something like that. Now, next one is, we have monochromatic and polychromatic sources. What is monochromatic?
Yes, sir. Sir, instead of the standard red, yellow, and green, they have a blue go light.
What is a blue go light? Go light.
Yes, sir.
Yeah, somewhere I have.
Instead of green. Yes, sir, in Japan.
I don't know. Huh? Yeah, somewhere the video has seen. That's what I'm saying. Now, monochromatic. Monochromatic means only single wavelength. Understood now? Monochromatic means single wavelength. Polychromatic means multiple. Okay. Polychromatic means multiple wavelengths. Understood now? Monochromatic means single, and polychromatic means only one color light. Monochromatic means only one color. But here this is polychromatic, multiple colors. Okay, white light. So best example for this is what? Sodium vapor lamp. Sodium vapor lamp. Okay, and this one is what polychromatic is. We have mercury vapor lamp. Mercury vapor lamp. Understood? Are you able to see, Dhruti, the board properly?
Yes, sir. I'm able to
Okay,
see.
please tell me if any instant. Okay, I have changed the location of the board. Now.
Yeah, so now it's fine actually.
Okay. Now, so in monochromatic it is single color, and polychromatic multiple colors. That is sodium vapor lamp we are using, and this. In street lighting system, have you seen what color light lamps will be there in street lighting?
So yellow.
Yellow color light. Okay, you know the cost of sodium vapor lamp and the current consumed by sodium vapor lamp is more than the tube lights, more than the white color lamps. You know that one? And the switch on light also, switching time is more for sodium vapor lamp. When you switch on immediately, it will not switch on. After 20 minutes, it will on. Means slowly the brightness of the light will increase. That is switch on time is 20 minutes for sodium vapor lamp. Whereas for tube light, it doesn't take much time. Only just switch on, immediately it will be on. Then why did these people spend this much money in the street lighting system?
So because the sodium vapor lamps last longer.
No, nothing like that. Tube lights stand long longer than the sodium vapor lamp. You know, in 1970s and 80s, they were using tube lights. They have replaced all the tube lights with the sodium vapor lamp. No, LEDs also they are using, but no, LEDs only for white color. For stadium and all, they will be using LEDs. And the street lighting is only at the roundabouts. Only at the roundabouts, they use mercury vapor lamp or white color light. But on the street light, on the main roads, they never use white color light.
Sir, because they penetrate mist and fog properly.
What is
Like
it?
they are, so if there's a mist or fog going on, so you can still see the light.
Yeah, you are very close to the answer. Whenever there is a fog or whenever there is a rain, what will happen? The raindrops are acting like lenses or prisms, like this. The raindrops or the dew drops are acting like prisms. So when the white light passes through these drops, what will happen? You will see the front vehicle in 7 colors. You will see the car which is in front of you in 7 colors. And you can easily dash, no? Many accidents used to happen before, whenever there is rain. Whenever there is rain or fog, so many accidents because of the light. Okay, because visibility is completely different, because you can see seven color lights, 7 color vehicles in front of you, same vehicle in 7 colors. Not able to, driver cannot judge which is the right one. So because of that, they removed all the tube lights and the white color lamps and they replaced with the sodium vapor lamp. Understood now? Is that clear?
Yes,
Is that
sir.
clear, all of you?
Yes, sir.
Yeah, so that is the reason. Okay, so that was about the this frequency and all. Scattering is not there. Next one is what we will go to the derivation. Okay, before that I would like to explain the I also. One is okay, in I only I will take 2-3 minutes to explain this concept. So what is the least distance of distinct vision? What do you mean by least distance of distinct vision? Yes. What is the least distance of? Anyone? This is in grade 10 again.
So it's the minimum distance till which an object is properly visible.
Yeah, the minimum distance from the eye to the object where the object is clearly visible, that is 25 centimeters. For the normal human eye, it is 25 centimeters. Okay. Now we have near point. Near point means it is a point very close to the eye. Still, till that point also you can see the object clearly, but it is painful. You can keep, if you look at the finger, you can see the finger still here, but it is painful. There is a pain on the eye. So this distance is 8 centimeter from the eye to this finger is 8 centimeter. So near point is 8 centimeter and least distance of distinct vision is how many? 25 centimeter. Understood now? Least distance
Yes,
of
sir.
distinct vision is how much? Least distance of distinct vision is 25 centimeter and near point is how much? 8 centimeter. Is that clear?
Yes, sir.
Okay, now
Yes,
we'll come to the accommodation. What is power of accommodation? Third definition. Power of accommodation. Yes. What is power of accommodation? Can anyone say that?
No idea, sir.
Power of
I
accommodation
remember.
is, see, when we see the object like this, our focal, the eye has a focal length. It will get adjusted to this distance. Now I am looking at a building very far from me, around 1 kilometer. So what happens? My focal length of eye will take few microseconds or milliseconds to adjust the focal length from the eye to that point. So how fast it does? Okay, means when you keep the object very close to you, the focal length is the eyeball will become like the lens will become like this. When the object is very far, it becomes very thin, like this. The lens will become very thin. So how fast it does from thick to thin, that is said to be the power of accommodation, or it is the ability of the eye lens to adjust its focal length. Ability of the eye lens to adjust its focal length as per the distance, object distance. That is said to be the power of accommodation. One more definition is there. So as you grow old, what happens? The power of accommodation will be reduced because the ciliary muscles around it will get weakened. So that is why when you go and meet your grandmother or grandfather or great grandfather and all, they will take some time to recognize you because it takes some time to form the image. One more definition is there, which is with respect to the brightness of the light. If the brightness of the light is more, what will happen? The pupil, very less amount of light will be allowed through the pupil. If the room is dark, the pupil will enlarge completely and more light will enter through that. Understood?
Yes, sir.
If the eyeball is very when the light is very bright, what will happen? Eyeball it will become very small, it will shrink, and it will not allow very small amount of light. If room is dark, it will suddenly open. Now suppose you are in a dark room and the pupil has completely opened. It is allowing most of the light to pass through the eye. Suddenly the light comes. Okay, the power comes back. What will happen? You will close your eye.
So you close your eye.
That situation is known as impulse response. That situation is known as impulse response. Is that clear? So that is why when a person is in coma or having some brain tumor or like brain hemorrhage or something, they check with the intensity of light, whether they put the torchlight and see whether the eye is responding to the top one. The eyeball is responding to the top one. Okay, that they see. So these are all connected one with another. Okay. Now, next one is what near point. Near point is also known as myopia. Means you can see near objects clearly, but you cannot see the far objects clearly. That is near point. Next one is what far point. Far point means you can see far objects clearly, but you cannot see the near object clearly. So myopia, there are two names for myopia: myopia or short sight or near sightedness. And the next one is long sight or hypermetropia, far sightedness. And presbyopia means having both at the same time. And astigmatism means like the object is not clear. Astigmatism is, suppose if you ask that person who is having astigmatism to draw this, he will draw like this. You see edge effect. Okay, he will draw in this way. Is that clear? If you ask a person, to draw this, he will draw in this way because it's a curvature effect. So it's a cylindrical phenomenon. They use a cylindrical lens for this particular concept. Okay, clear? Is this clear, all of you? Is it clear? No one is responding. Yes, Dhruti, Ashas, Arham.
Yes, sir.
Okay, yeah. So I'm going with the derivation. Now, my theory part is almost all done now. I'm done with the theory part. Now, one aberration part is that aberration I will teach with the telescopes. Okay. So one is we have linear magnification, we have aerial magnification. Linear magnification means size of the image by size of the object, or image distance by object distance is said to be linear magnification. And the second one is aerial magnification, area of the image by area of the object. That is said to be aerial magnification. Is that clear? Now, so that's about the derivation, the theory part. Now I am going to start with the derivation. There are around 6 to 7 derivations in this lesson. I'll start. All the derivations are important. These two lessons I am telling you carry more mark. This ray optics and wave optics, you can expect a case study from ray optics or wave optics. Definitely one case study will be there. One case study is from current electricity, no doubt about it. Keep that in the mind. There will be how many? Three case studies, right? 3 or 2? 3. One case study you can find from from current electricity. One case study from ray optics or wave optics. One more case study from EMI chapter, electromagnetic induction chapter. Okay, very, very important. Anyways, I'm going to discuss few case studies because you don't know what type of case study they'll be asking, but the concept I will tell you what type of question they can ask. Okay, so we'll try to solve some sample papers and some question papers, then you'll get an idea. Okay, so see, it's not like last year. Last year it was like 2 terms, 35, 35. It was very easy to study, easy to prepare, only half of the book to study and half of the book to write. But here it's not like the 70 marks at one stretch. Is that clear? And the time for writing the paper also was more last year. 35 marks, it was 2 hours. Here also, second part also 35 marks, 2 hours. But now it is how much? You're writing 70 marks only for 3 hours. Yeah. So, and also physics paper is the one which takes more time to complete. Okay. Paper will be lengthy. Now, the first derivation we will do, that is what? The first derivation is here. That is to prove. Now, here we have to prove that R is equal to 2F. You have to prove this derivation. Okay. To prove that R is equal to 2F. Okay. Now, here in this one, what is there? Here we draw this. We already know. We studied in grade 10. We know that R is equal to. So here, what will happen? This is a mirror. So mirror was deleted last year, but this year they kept everything. Okay. So there is a mirror like this, and this is the pole. P is the pole. A ray which incidents in this way, it will pass through the focal point. Okay, it passes through the focal point. Now, it passes through the focal point. Is that clear? Now, what happens here? This angle is what? This angle is said to be 2 theta. Understood now? If this angle is 2 theta, this angle also will be 2 theta. But what we are doing? We are drawing a normal. Okay. We are drawing a normal. A normal is a line which passes through the center of curvature. Normal is a line which passes through the center of curvature. This is theta, and this is 2 theta. So how much it will be? This will be theta, and this also will be theta. Is that clear? Once again, this is the angle of this is the incident ray. This is the reflected ray which passes through the focal point, and the angle here, if it is 2 theta, the whole angle will be also 2 theta, right? Adjacent angles. This whole thing will be 2 theta. But what is this line? A line which passes through center of curvature is a normal. Or we can say this is said to be bisector. We say normal or angular bisector. What do you mean by angular bisector? Anyone? What do you mean by angular bisector? Can anyone say this?
Which bisects 2 lines.
Bisects the angle into exactly 2 equal halves. Okay. So now here we are taking, because the concave here, this is M. I have taken M here. Okay, see D, sorry. This point I will take D, and this is M. Understood now? Angle here we have angle NCP, which is equal to what? Theta. And we have angle MFP, which is also equal to what? 2 theta. Understood now? Angle
So
MFP
what is MD?
So from right angle to triangle.
Sir,
Yes.
so what is MD?
MD is a projection of M on the principal axis. Line
Okay,
or
sir.
projection of M on principal axis. They where D and P is very, very close. Why? Why it is so close? Why it is so close? Because we are speaking about thin lenses and thin mirrors. We are not speaking about thick lenses. Understood now?
Yes, sir.
We are speaking about thin lenses and thin mirrors. Okay. So angle MCP equal to theta, angle MFP equal to 2 theta. So from right angled triangle MDC, right angled triangle MDC. So MDC, which is equal to what? Tan theta is equal to what? Here we have tan theta is equal to opposite side upon adjacent side. Okay. Tan theta is equal to opposite side by adjacent side. Okay. So here we can write tan theta is equal to what? Tan theta is equal to MD by DC. Okay. Tan theta is equal to MD by DC. Is that clear? Again, from right angle triangle, this is the first one. Again, from right angle triangle. From right angle into triangle. So we have MDF. Okay. MDF. This is a second right angle. So we have what we have here, tan 2 theta. Tan 2 theta is equal to again opposite side by adjacent side. MD by DF. Okay. MD by, it is equal to MD by DF. If theta is very small, if theta is small, what will happen? Tan theta is equal to how much? Tan theta will be equal to theta, and tan 2 theta will be also equal to 2 theta. Understood now? Tan 2 theta equal to 2 theta. So now what will happen? So we can write what is theta here. This we can take it as theta. Theta is equal to what? MD by DC. And here what is the 2 theta will be equal to MD by DF. Okay. So now what we are writing, 2 into theta. What is theta here? Theta is MD by DC, which will be equal to what? MD by DF. Okay. MD by DF. Clear? So what will happen? MD and MD will get cancelled. So what you are remaining with now? That is what? FD is equal to how much? DC by 2. Understood now? FD is equal to DC by 2. Or we can also write F equal to R by 2. Is that clear? F equal to R by 2. This is the formula for the focal length. Is this clear? Where FD will be equal to F, FD will be equal to F, CD is equal to R. Understood now?
Sir,
Yes.
can you tell what RA is again?
Can you say it again, please?
Can you tell me what RA is?
R is the
A.
radius of curvature. RA here, right
RA,
angle to
yeah.
triangle. From right
Oh,
angle to
okay.
triangle. RA means right angle to triangle. Okay.
Yes, sir.
So this is the first derivation. Okay. So if you have any doubt, please tell me. Then we will start with the second one. Huh? Yes.
Sir, can you explain it once
Yes, sir.
from the start? Sir, can you explain it again once?
Okay. Okay. 1 second. 1 second. Now, so now see from the beginning once again. What what we have to prove here? R is equal to radius of curvature is equal to 2 times the focal length. Now this is a concave mirror. This ray is incident on this and will after reflection passes to the focal point. And the second ray, what happens? This is a n is what? N which is passing through center of curvature. It is a perpendicular or angular bisector. If this angle is 2 theta, this also will be 2 theta, and this is theta. Understood now? Now angle MCP will be equal to theta and angle MFP will be equal to 2 theta. From right angle to triangle MDC, tan theta is equal to opposite side by adjacent side, and then just substitute, you'll get the answer for that. Similarly from right angle to triangle MDF, tan 2 theta from 2 theta is equal to MD by DF, or 2 theta is equal to MD by DF. So 2 theta is the opposite side by adjacent side. Here opposite side by adjacent side. Now what we have done? If theta is very small, tan theta will be equal to theta, and tan 2 theta will be equal to 2 theta. Now take 2 theta, 2 into theta will be equal to that value. Substitute and cross multiply and cancel it. Okay, you'll get the answer. Here?
Yes, sir.
Okay, so we'll go ahead now. Yeah, next, shall I go with the next second derivation, Dhruti?
Yes, sir.
Okay. Yes, Mr. Rashaz and Arham.
Yes, sir.
Yeah, next one. Now, the next derivation, it says that to derive mirror equation. Okay. The second one is to derive mirror equation. We already know mirror equation is what in grade 10 we studied 1 by f is equal to 1 by v plus 1 by u. Okay. Now there is this is a mirror. This is a mirror. Now what happens? F is the focal point. C is the center of curvature. F is the focal point. C is the center of curvature. Now I take object here somewhere here like this. What is that? AB. AB is the object. Now, so now we take two rays. A ray which is parallel to principal axis after reflection passes through the focal point. Second ray which passes through, which incidents obliquely like this. What happens? It will reflect back to the same angle, right? It will reflect back to the same angle. Maybe the image is formed somewhere here like this. Okay, it should be formed somewhere here. Okay, if this is C, the image is formed like this, A dash, and this is B dash. Image is formed somewhere like this. Okay, please draw the rays. Without rays, it is incomplete. And what is this? This value is F. F is the focal length. And what is this? This value is what? This is U, objective distance. And this value is V, image distance. Okay. U is, F is small f is focal length. Small f is the focal length. U is objective distance. U is object distance. And V is image distance. V is image distance. Understood now? So U is object distance and V is image distance. Okay. So now here coming to the right angled triangle. So coming to right angled triangle. So which triangle? A dash, B dash, F and MPF. A dash, B dash, F and MPF. Okay. A dash, B dash, F and MPF. So what will happen now? Okay. So MPF, we have to we are taking the ratio of this. What is this? A dash, B dash, F, A dash, B dash, F and MPF. What is M? Here I'll write that MPF. This is M. This is P. This is MPF. Okay. Now, so what we are writing, we are taking the ratio. What is that? B dash A dash divided by PM. B dash A dash divided by PM is equal to B dash F by FP. B dash F by FP. Okay.
Sir, can I leave? Sir, can I leave?
Yeah, you can. You may leave.
Okay,
So
sir.
FP, which is equation number 1. So we already know that PM is equal to what? PM value is equal to AB. PM value is equal to AB. And also we know that angle angle APB is equal to angle A dash B dash. Okay, A dash B dash. This is the angle. So we have B dash A dash by BA. B dash A dash by BA will be equal to what? B dash P by B. B dash P by B. Is that clear? So that is equation number 2. That is equation number 2. That is equation number 2. Now, from 1 and 2, what we write here? From equation 1 and equation 2. What do we get now? B dash F by FP is equal to B dash F divided by FP will be equal to what? B dash F is how much from here to here. This can be written as what? B dash P minus FP. B dash F, which is equal to B dash F minus FP divided by what? Divided by FP. Divided by FP, which is equal to what? B dash P by B. B dash P by B. Okay, so that is the answer. Now, this is equation number. So we have B dash P will be equal to what? Minus V. Minus V. FP will be equal to what? Minus F. And BP will be equal to minus F. BP will be equal to minus F. Now we'll substitute all the values in the equation. So what will happen now? Just substitute here. What will happen? Minus V plus F. Minus V plus F divided by F will be equal to B dash P minus V by minus V. Minus V by minus. So this minus will go away. This minus and this minus will go away. So what is left? When you solve it, it will become 1 by F is equal to 1 by F is equal to 1 by V plus 1 by V. Simplify it, you will get directly this one. Is this clear? Completely mathematics, okay?
Yes, sir.
Yeah, minus and minus will cancel, no? They're cancelling, go to minus. If you have any doubt, please tell me. Yeah, done. Can I go with the continuation of this one? The magnification thing.
Yes, sir.
Next one here we have, okay, I'll do the magnification part here. Okay. Now, so here we have triangle. Triangle A dash, B dash, and C, and triangle ABP. So what happened here? B dash, A dash divided by BA equal to what? B dash B divided by B. Okay, so that will be equal to minus H dash by H, which is equal to minus V by minus U. So what do we have now? M equal to H dash by H, which is equal to minus V by U. Is that clear? So minus V by U. So we can also write here H dash by H is, this is the formula, that's it. Magnification formula. Height of the image by height of the object, which is equal to image distance by object distance. Clear with you all?
Yes, sir.
Okay. So I'll not start the new derivation now. I will stop the derivation here. Okay. But for today, I'll stop it here. So tomorrow, can I continue then?
Yes, sir.
So tomorrow we have a festival, sir.
Tomorrow or day after tomorrow? When is it?
2 days, sir.
2 days, then relax. Okay. I'll not take any class
Yes.
for 2 days. Relax, then come back on Tuesday, Monday, right? Tuesday. So Sunday, Monday will be holiday. Okay.
Thank you, sir.
Okay. So take care. So happy Diwali.
Thank you, sir.
Okay then. Take care. Bye.